Hello and welcome to Void Electronics. This is the first follow-up in the Guess the Part series, so it's time to reveal what this component is. We can simply turn it around and you will see what it is. But before doing that, let's talk about what your answers might have been in the meantime. So maybe some of you thought that it is some sort of AC motor, and this is essentially wrong, but you wouldn't be far off, let's say. And maybe some of you also guessed that this is some sort of encoder. And once again, this is essentially wrong, but once again, you wouldn't be far off. So yeah, I think things are getting really interesting at this point, because you may be wondering what such component could be that is let's say a hybrid between an encoder and an AC motor. Well, as it turns out, there is such a part, and it's called a synchro transmitter or a cell scene. In this case, we have a Muirhead E2H1 synchro transmitter. So what this is some sort of encoder used in AC circuits, which is really interesting. So let's see what it has inside. Well, we have a clue right here on the schematic diagram. This one says 50 volts or 57 volts and 50 cycles per second, which implies that it is some sort of AC component. So here's more or less what it has inside. So it has a winding with two terminals X and Y, and it also has a set of three windings with terminals 1, 2 and 3. So what happens inside is that we have a rotor, which in this case has the X and Y terminals, that spins inside a set of three windings that have these three terminals 1, 2 and 3. And as you can see right here, the stator windings are 120 degrees apart from each other, and since the rotor is excited by a 50 Hz sine wave at 50 volts in this case, the rotor induces a voltage in the three windings right here. Now the interesting thing about this is that since the rotor can spin, as you spin it, it gets more or less aligned to each of these windings in the stator basically. Which means that for every single position of the shaft right here, we get a specific set of values for 1, 2 and 3, let's say. And by values I mean basically the amplitude of the sine waves that we have at the output. And interestingly enough, this forms a really special type of encoder. Now, such an encoder was used extensively in all sorts of applications. It was really common in airplanes. More specifically, all the analog instruments inside the airplane had something like this behind. So for example, you could have a synchro transmitter like this one on a sensor that would turn it based on the temperature that the sensor senses or based on the pressure or something like that. And the angular information would be sent via three wires to what we call a synchro resolver, which could be part of the instrument in the cockpit. So as the sensor would spin, the exact position of the sensor would be transmitted to the cockpit. And this way, you could have an electrical link between a mechanical sensor and a mechanical indicator, if you will, or an instrument. However, the synchros used in aviation are 400 Hz, because that's how airplanes run, so this one is almost certainly some sort of terrestrial application. I'm not really sure about what the typical application for such a thing might have been actually. So yeah, let me know if you knew such thing existed, and stay tuned for a follow-up where I want to do some experiments with a few of these. That's it for now. Bye.